So what I'm going to talk about today is how we deal with privacy engineering. And despite me being in the Faculty of Computer Science, I called my lab security and privacy engineering with all of the risks that that has. Because when we talk about privacy, engineering is extremely important. How we're going to integrate the technologies that we put in the systems is actually non-trivial. And back in 2010-ish, around that, well, people started to think that, this privacy thing was kind of important in the digital world. And this started to make it a lot into the policymaker side. And everybody agreed that we would love to have this thing called privacy by design, which means that everything we create kind of has privacy from the beginning, and we're going to have users protected, and life is going to be fantastic. And here I just have 3 examples. The first one is from the Privacy Commissioner of Ontario in Canada, which was one of the first kind of articulating these principles and kind of integrated it into policy. And Anke Buchian, Commissioner at the time, kind of put these principles ahead that you can read here on the left. And then she had these very enlightening sentences such as privacy by design is embedded into the design and architecture of IT systems. And this kind of thing also made it in other regulations like the GDPR, which by now everybody should know, right? That says that the controller shall implement appropriate technical and organizational measures which are designed to implement data protection principles. And this is not only on this side of the ocean, also in the United States, the FTC has similar kind of ideas that says that companies should incorporate substantial privacy protections into their practices, data security, collection limits, protection practices, data accuracy, and all of this is great. And nobody can kind of deny that, of course, this is the world we want to live in. But now you, like me, are not policymakers, are not probably CEOs, are not managers, are actually engineers, and you read all of this thing, and then it really feels a little bit like this. Like, it's great, we love to have it, but how on earth I'm gonna do this thing, right? How do we do it? So when we started reading all of these things, we decided that we had a lot of expertise, like the research field on privacy by 2010 was kind of starting to be mature in the sense of already had 10 years of existence, with a lot of ideas. We were thinking about, okay, how can we help engineers actually unpack these sentences here? How can we give them guidelines and tools to actually draw the freaking all? And back in 2011, we said, oh, we have the solution, right? The solution is that when we want to build privacy, what we want to do is data minimization. So systems that don't use data, because the less data we have in the system, the more privacy preserving it is. And we wrote a paper that was published at Computer Privacy and Data Protection. This is an interdisciplinary conference that has computer scientists and policymakers. And it was super well received because it kind of had clear ideas that resonated very well with policymakers because it's clearly related to the data minimization principle in the data protection regulation, which says that you should only collect the necessary data, kind of the minimal data for the purpose of your service. So everybody kind of seemed that it was that this was a good way to go. And then when we started thinking more and kind of articulated and unpacking more this thing, we realized that we don't minimize data in the system. As engineers, when you think about it, data exists, right? Because data always exists everywhere. And we will see this in my examples of the contact tracing apps, because either data is kept in user devices, or maybe you send it encrypted to a server, or maybe you distribute it with multiple servers. I think Mira and Brian are going to talk about these things today. So you can do many things with the data. But data is a little bit like energy, right? It does not disappear, it just gets transformed and put it another way so that we can use it. So we came that data minimization, just by itself, is actually a bad metaphor to explain to people how to build the privacy preserving design and how to get to the goal that the privacy preserving design is. And then we realized, kind of going back to the literature, that mostly what we do is really kind of, when we do privacy, try to minimize the privacy risks, and we do that to minimize the trust assumptions that we put on other entities. And kind of other entities and how we model other entities is a key to what kind of privacy technologies or what kind of techniques that you need to use. And if we look at how privacy is treated in the world, we can roughly divide this kind of in three type of adversarial entities, because privacy is kind of a security discipline in which we think about who wants to violate privacy is kind of an adversary, right? We have the same kind of reasoning that security engineer is, and you could have as an adversary like other users or third parties. This is the kind of thing that we typically see on online social networks, like on Facebook or Twitter or LinkedIn, where we give all of our data to the provider. And then we tell the provider how to kind of protect it from others, from other users, like with our privacy policies. And it is protected from third parties, like it goes encrypted through the network, and then we are kind of assured, sort of kind of by Facebook, that it's not going to give our data to others and so forth. And then we have sometimes that we have a regulation that says, okay, the provider is not completely trusted. We kind of put some legal boundaries on it so that we ensure that it is harder for them to misbehave. So I need to trust them less. This is typically not really a by technology assumption. It's actually a kind of legal assumption that because there are fines and there are legal implications for them, it is harder. So I can trust them more because it is harder for them to misbehave. And then there is the world of the people like me that design privacy enhancing technologies, that when we think about the kind of this adversary, at the end of the day, everybody's the adversary, including the server. And kind of the goal is to be able to build a system in which I don't need to trust anybody but me to actually get privacy protection. So that was good. And then we were like, okay, this also helps. But then we're talking also with practitioners, we discovered that this was also not very helpful for them. Because this idea of trust and modeling, comes from security engineering, but really is not something that every software engineer or every developer or every software designer is actually used to do. Like thinking in an adversarial way, kind of complex. So lately, I really explain this more, like how do we minimize trust? Minimize trust through another kind of something that we can link to a legal concept, which is the concept of purpose limitation. The fact that you can only use the data you collect for a particular purpose. And the typical approach that we have when people design systems is that they think, okay, let me get all the data I can, every data as much as I can, right? Because, and then I'll see how to use it, but the more data I have, it's going to be better. And then comes your legal department, and then comes the DPO and tells you, you cannot collect all these things because we cannot actually find a sentence to put on our privacy policy to justify that. And you end up collecting less data. But as privacy engineers, we think in a very different way. We actually first think like, what is the purpose? What is the essential purpose of this application? And we think about what would be the data needed for that particular application. So an example of this is back in 2010, we built a system for pay-as-you-drive, in which we think about what data do I need to collect for charging people depending on how much they drive and which type of roads, etc. And initially you may think that the data that you need to do that is actually where these people went, like GPS traces. But actually to charge people, depending on how much they drive, the only thing you need to know is the final amount of the bill, right? That's the only thing you need to know to charge them. I need to know that you need to pay me 100 francs. But I don't need to know where you went. I just need to be sure that 100 francs is your bill. So that's kind of the data I need for the purpose. And indeed, you're also thinking, but you need to make sure that actually 100 francs is the correct amount. So I may need to collect other type of data to make sure that the amount that I'm getting or anything to get assurances that the data that I need for the purpose is authentic, is good, keeps its integrity, and actually corresponds maybe to the service. And how we kind of move in privacy engineering is by trying to do this using what we call privacy enhancing technologies that allow us to, again, not collect the pure data, but collect kind of different proofs and attestations that essentially the final data I'm using in my system is correct. So there are some operational purposes that force me to collect more data. And what happens when you think like this is that this blue triangle here, the data I will finally collect, is always smaller or at most equal to the one that you have here. So we always end up with this. And it also so happens that by thinking in this way, you're constraining also the use of the data that you collect to this particular purpose. And that's what allows you to trust very much the server, because you don't need to trust them to not misbehave and misuse the data, because they cannot. The purpose is encoded in actually how we engineer the system. And in this sense, this kind of technological purpose limitation that limits the need to trust is actually a good metaphor when we think about what is the goal when we build the privacy to preserve and design. What is the goal of privacy? The goal of privacy is not to remove data. The goal of privacy is to avoid that the system misbehaves, and we can do that via technology. And yeah, that was good. We were here. That's a good idea. We can do that. But now we go back and we see, hey, can people do this? And if you go to the literature of privacy enhancing technologies, people have been doing this for a long, long, long time. But the thing is that when we look at the papers and when we look at how this works, and when you also look at this little triangle that I put here, this might remind you at the waterfalls over development, right? When we have requirements, we decide the purpose, then we design, we develop, we verify, deploy, and then it's maintenance. And this thing, if you squint at it, should very much remind you of a thing we're very used to do, which is the outline of a paper, where you write the intro, then you write requirements, the design of your system, your prototype implementation, your evaluation. We don't deploy that much, and what's maintenance, right? You just publish the paper and you're gone. But essentially, this is how academia works in that sense, because we don't have to deal with this. But when you move to the software world, when you move to actually practice, this is the past. Nobody ever anymore does things like this. They don't really have kind of an idea what is the purpose from the beginning. Now we live in an agile world in which we have requirements that evolve over time in every agile cycle. And we have testing and release, yeah, because we have this feedback step here. And that actually changes everything. So this kind of thing doesn't work anymore. And therefore, the way in which we reason in academia kind of doesn't fit that well. And the kind of privacy technologies we produce are not very much in sync with what the real world needs. And also because the real world, this doesn't kind of build monoliths. We don't build anymore something from scratch, right? We build things that are service oriented, in which we use a lot of building blocks from others. And these building blocks turn out to have a strong impact on privacy engineering because they constrain the choices that you have. They constrain the kind of design space because I cannot anymore decide what is going to be maybe the minimal data I get, because I'm going to get data from the service here. And maybe the service is going to give me it in a format or in a quantity that is not exactly what I would do. Would I be the privacy engineer that designs the monolith? And this essentially changes a lot of things. And to give an example of how this works in reality, let me talk about my experience with the content tracing data, because we hit each and one of these hurdles. And just to refresh everybody, what was this about? Back in March 2020, probably you don't remember, this was like 3 centuries ago. There was this thing called the pandemic that started. And the kind of main tool that we have to stop epidemics and pandemics is what is called contact tracing. The great change of infection by means of telling people that may be infectious to stop their lives, to quarantine so that they don't infect others. But what happened with COVID is that the amount of cases that we had made this impossible to do the traditional way, which is human to human. Infected person, so positive person talks to doctor, doctor calls contacts, contacts get quarantined. But with the number of cases that we had, it was impossible to actually kind of maintain this infrastructure. So the idea was that we would have some technology that would help this thing and would help us get to these contacts faster, to notify them faster, like in a timely way, more efficiently, without the use of that much human power, because we could not scale the number of humans that were doing this thing, and also scalable not only on the human side, but also on the technology side. We were not thinking for a technology that works for 100,000 users. We were going for a technology that works for every Swiss, which is 8 million, but every European, 500 million, and ideally the world, right? And this is kind of a very big scale. And as software engineers, you know, it's not the same thing to design for 100 at for 100 million. And the proposal from the beginning was to use an app. Why an app? Because back then we didn't have the time to design a new sensor and super cool device and give it to each and one of the Swiss. Like, how did you going to go door by door? By the time you end, maybe the pandemic was ended. Given this time, maybe we would have had the time to get there before the pandemic ended. But anyway, the app was kind of an easy way of getting to the sensor that everybody has on their pocket, called the smartphone. But when this got to my team, right, we understand that you don't build an app. An app is just this thing that is on the phone, this little icon that runs there. But to build an app, you need to build a building infrastructure that takes the phone sensors, but there is also the network. There are also backends that need to be built. There is UI that needs to be built. And that will create a lot of dependencies from the mobile operating system, from the cloud infrastructure. And a lot of this is mainly privatized because health systems in the world, let's face it, have very little infrastructure of their own. And even there are few countries that have the capability to even kind of span clouds on their own premises. We're lucky to live in one of the ones that actually can, but this is not possible for everyone. So when we heard about this, we got very worried, because when we talk about infrastructure, the thing changes. And why does it change? Because infrastructure, digital infrastructure, you have to think it as a road. Once you build it and once you put it there, it's hard to remove. Like, it takes a lot of effort and investment. And once you put it there, people are going to be able to want to use it. You put the road, and even if the road kind of, gets a little bit more abandoned because another highway appears, the road is still in use. And if you have it there, it will be used. So if you collect data, you create an infrastructure that has something, you can be sure that somebody will have a brilliant idea about why don't we use this now for something else. And once you have that, it is also very hard to control, right? And when we started this and we said all of these things, people were like, oh, the privacy advocates, they just think the worst. But all of the worst things that we've said happened, each one of them. In different countries, we saw how both data collected for COVID on paper or on electronic form was misused by law enforcement, by people that got access to it. We just saw last week, there was this news from this week actually, on Australia just lost data, just leaked the database, 100,000 locations that had COVID for the kind of contact tracing where you actually kind of get records of locations, databases of location. All of this was lost, right? So this is actually important, because once we have it, like, we cannot control what is going to happen with this data. Like, it is unreasonable to think that this infrastructure is not going to be misused, and in ways that we are not going to be able to. We also have several examples in Germany of how the data, like more modern than this, how data collected for COVID-19 contact tracing is being used again and again in police investigations. So in this scenario, we thought, like, okay, what are the constraints that we have to design this thing? The main idea, of course, is protect the most highly sensitive, which is health-related data, which is positive. But he also wanted to make sure that all of these things didn't happen. So protect from misuse. Misuse that would be used for surveillance, for manipulation, as we saw for law enforcement, for stalking, any kind of reason. And that indeed goes back to say we want to do purpose limitation. And our purpose is to notify people. This system should not do anything else. All of the other ideas, if you want to build a system that besides notifying allows you to collect statistics and knowing where the virus spreads, those are different systems. But we were not asked to do that. We were asked to build a system that notifies. So we had a purpose. And that meant that we needed to protect the information that we know from the literature, we know from years, that is the one that has easy reuse. And that's the user's identity, their location, where they are, which is actually very much related to their identity, but also to their inner them, right? Where you go actually says a lot about what you like, what are your habits, this kind of thing, and also your social behavior, social graph, who you meet, how often do you meet them, for how long? Because if you know these things, you start to learn a lot about the person and the relationships, right? And those are the kind of things that we have heard in the past that were very much used for different things, either whether it is by industry to personalize services or for law enforcement to run investigations. So we want to eliminate all of this information And of course, we also need to take care of the security side to prevent false alarms. If we ask people to put this in their pockets, but then there are a lot of false alarms and they don't believe on it anymore, and the system has to work. If we have denial of service very easy, then why do we have a system, right? It's a lot of money. So what we built is a system that was based on the sensors that were available on the phone at the time, and that is Bluetooth. And how the system works is the phone every day generates a key, a cryptographic key, and from this key, it derives what we call random identifiers, which are these kind of random numbers. And these random identifiers are changing. They change every roughly 10, 20 minutes. And well, when you have a random identifier, you just go broadcasting with the beacon. And the people around you do the same thing. And when users are close to each other, they hear these beacons and they hear these numbers. And then they kind of note down, I have seen this number if you're close enough. So B is close enough from A and C, so we would have 2. But A is only close to B, not to C, only has 1, so 4. And besides this number, we also record the power of the signal. The power of the signal is a power of distance as it is volume on the voice. If I come closer, you hear me higher. If I go further away, you're going to hear me more muffled. So that's the kind of information you have. And then eventually, when one user has the bad luck of actually being infected with COVID, the doctor can give them an access code. You can think like this is a one-time password or something like that, that allows them to upload the keys of the days that they were infected to a server. And then the rest of the users download these keys. With these keys, they can derive these random identifiers that this user has been producing during that time. And they could go to the list and they see, did I see any of these random identifiers? And if they saw them, then they keep accumulating them with this power measure. And at the end, they make a global computation with all of these power measures that will tell them whether they were close enough to that person, given these power measurements, and for long enough time, how many measurements you have, and what are the timestamps. And then if that means, in the case of Switzerland, that you have been close to a person, close being less than 1.5 meters for more than 15 minutes, you will receive a notification. If you know in Swiss COVID, this tells you to call a hotline where they give you more information. And the kind of the key thing here is that the only information that leaves the phone are these keys only during the infected period. And these keys are not related to the identity of the user because it's a random number created by the phone. They're not related to the location because the derivation of random identifiers follows a predefined schedule depending on where you are. And it does not information about others because regardless of how many people you met, you will always upload 1 key per day, right? So with this, we kind of ensure that this server here doesn't have any of the information that could actually be used for any other purposes. And then there is no abuse possible by means of just not having information. Another very important thing that we had in mind is that we were pushing a system on people at a time of emergency where people would just accept anything. And at that point, we were desperate, and anything that there was a hope that the hell would end would be accepted. We wanted to give the power of shutting down the system, not to the governments or to the people developing the system, but by the users. So in this system, because the system works with this loop where users upload and then download, if users stop uploading, it doesn't matter if the government keeps the service running, right? The users have the power, the citizens have the power to shut down the system by themselves, also helping with this idea that the system is not going to be available for abuse or anything, because we just can kill it. Even like the moment that we feel as a society that this is not good, we can kill it by ourselves. Okay, so that is cool. And that's what we explain the world. And that is the protocol. But it turns out that the system is much more than a protocol. As I said before, right? System is built on other things. And there's a mobile operating system you have to build on. There's an application you have to program. There's a health system you have to integrate on. And that means that the privacy engineering does not stop at doing a protocol, Bluetooth. We have to do much more. And I'm going to talk a little bit today about this part here that we never talk much about, but it has a lot of privacy implications. especially because the network traffic that just indicates that somebody uploads a key to the server actually reveals something. In my explanation before, the only people that upload are the people that are COVID positive. And back in 2020, I mean, nowadays having COVID is just like, who doesn't? But back in 2020, this was really a kind of a problem because people were very, very afraid of stigmatization, of knowing, so we could not reveal this information. And in any case, this information is protected by law, right? Your health status. So as the system stands, the user, whenever they upload keys, they are actually revealing to the world, just by this connection, they are COVID positive. And in the privacy literature, we have a solution for this. It's called dummy traffic. Means have other people just send in also at random fake things so that you cannot distinguish. Easy peasy, man. We have this in zillion papers. I have a bunch of those. We're great at this. But it turns out that on those papers, we cheat because we know everything and we have full control on the phone. Now, in reality, we have many problems. First of all, is that what is the user's behavior? We're in the middle of a pandemic. I mean, nothing in 2020 was normal. Nobody knew how users behaved. How do you know how users use this application? How often will they send? How often will we have, there is no models, there's no prior data. So we have to deal with a huge uncertainty that never happens in your paper because you say, I'm going to model this as a poisson, and off you go, right? But it turns out that reality may not be a poisson. And then we also had other constraints that never happen on your paper, because on your paper, what is a constraint, right? You just say, I assume there is no constraints, and off you go. Now in this phone, there are a lot of constraints. One of them is battery. It turns out, and I learned about this a lot by working with Google and Apple very closely, that one of the things people care the most about their phones is actually battery consumption. If you put an application that's going to kill their battery in 3 hours, they're just not going to install it. So you cannot create dummy traffic that is going to be operating all the time. That could give you very good privacy. It will also kill your phone, right? And that is not working. We also have bandwidth constraints. In most countries, internet service providers and mobile providers were extremely generous and made all of this traffic free. But still, you're putting a cost on the system, cost and economic cost, but also a cost in the sense of plugging the network, right? So we could not just throw there as many dummies as you want, which is something, again, that I would do on a paper. I would plot a very pretty graph where as I increase my dummies, I get more privacy and say yeah, if I put 1 gigabyte on the network, nobody knows anything. That's very cool. Now go tell Swisscom that I'm going to just throw a gigabyte on the network just for fun, right? So it's not going to fly. We also have the problem that it turns out that phones, because they optimize battery, they also had extremely strict uptime constraints for applications. Applications in the background, they don't really get a lot of computer power. It's very hard to get them to even have something to run. And how our applications that we do say now, but oh man, come on, my WhatsApp receives messages all the time. And that is because they actually receive pushes, right? They receive another trigger that makes them wake up. But the systems, the operating system of the phone are made such that if you don't receive any indication from outside, either the user or a push, applications get nothing, right? And then actually Google and Apple had to modify some of these things to make these applications run on the back, but still your uptime is not warranted. And then because Google and Apple are how they are, they also decided that there would be some user interactions mandatory. Another thing that we have to take into account is the service capacity, because it turns out the servers have a capacity. I know, the cloud is very powerful. The cloud nowadays, you just, spin another node and you're going to be happy. But every node that you spin costs money. So if we actually would make the Swiss government or any government have to spin 100 nodes just to handle all of this traffic that is quote unquote for nothing, they would get very upset. Actually, the cost of these servers is pretty big. And some countries that actually run their service like Ireland or Spain, the service for their apps are on Amazon, are very worried about how much I'm going to have here because it's going to come back in the bill. So we needed to make sure that this was also very reduced. And as I said, the system is built on a service. The service is in the Google and Apple GAIN. GAIN stands for Google and Apple Exposure Notification API. And that means that we don't have full control on all operations because we can only do whatever Google and Apple decided I was good to do. And And it's like that. I don't know how many of you usually program applications on phone, but more and more Google and Apple kind of constrained all of the things that you can do by means of these APIs that they sell us as they're wonderful because we can do all of the wonderful things, but only in the exact way that they allow us. And it may be that the exact way that they allow us is not always the best from the point of view of practice. In practice also, we had another service. If you remember, I said the doctor gives you an authentication code, and the authentication code you open. You set this here, but the doctor does not get the authentication code from the floor of his office. The doctor has to get this from the system, and actually we build the authentication service because that's what makes sense from a software engineering perspective and from a good practice as a separate service. And how actually it works is that when the doctor requests an access control code, requested from a second server, let me call it the red server just as for simplicity, gives you the access control code, but the black service knows nothing about this access control. So to actually get permission, you have to redeem your code, get a token. This is a JWT token, JWT token, signed by this red server. That is what you can give to the black. The black will say, oh, I have this thing here, has been signed by something I trust. I'm going to allow the upload of the keys. But now this thing here turns out that it's another connection from the user. And it's another connection that would reveal that the user is doing something that other users are not doing. So the dummies also must copy what the authentication step does. And that means that now the dummies are also constrained what the authentication service can do or will do. And it also means that not only this guy here has to take into account their dummies, and sometimes you're going to send things that they have to drop. Also, this guy here has to know that in the system there exist dummies, right? Again, I'm including a service, but this service has to be knowledgeable of my privacy policy. If I would take a random server on the internet for doing this thing, we would have used OAuth, for instance. OAuth doesn't give a shit about my privacy policy, right? Or out of Google, they have an API. I can use the API as is, but I cannot send to the API something that maybe is fake and is wrong. But in the one we built, has an option that actually knows when this authentication request is for a dummy and does things. And another among things that they have to do, they have to ensure that all of these operations take the same time and volume, no matter whether they're real or wrong. And this requires collaboration of a service. And if you don't control the service, then your privacy is not possible then. Just for more fun, as I said, Guyan decided that there was a pop-up. They would put that whenever you want to upload something, whenever you ask the API, give me the keys to send them to the server, Google and Apple put a pop-up themselves, have nothing to do with you. It is unavoidable that asks the user, do you really, really, really want to do this thing? Very nice. I appreciate this from a privacy perspective. Now, that means that in this process here, it is not completely automated, because once the token comes back, it's only once this has succeeded that our good developers of the application kind of ask the API to release the keys. You don't want to release them before you actually know you have authentication. And then there is a time there, that is a user dependent time until they click on OK. Then we can model. How do we model this thing? Like, we don't know. Are they going to take 1 minute, 10 minutes? I mean, these are people very stressed. They just have been told they have COVID. No idea. So we needed to create a way of doing random delays on the dummies that would actually cover for this kind of a problem. While you have also, again, remember, we're very constrained on the amount of time we have on the computer. And you see how all of these problems start to pile up. And none of this would ever happen had I actually done this in a monolithic, waterfall way, because I would have full control of everything and everything would be my decision. Just for more fun and as a detail, in the early versions of the exposure notification API, Google and Apple made a decision for security that we never understood, which was that the last key, so the key of the current day, would only be revealed after it expires. The idea of this was that if you reveal it before, then somebody that gets these keys can produce random identifiers in the future. And their idea about this was that this is the only way of solving it. This is not true. We actually had a different way of solving it that didn't require this thing, but that meant that you needed to upload a key also the next day. And that meant that when we do this dance, first time you can upload all the keys by the current one, and then we would have another upload the next day. Now the dummies have to do the same. Again, you enter in all of these problems that what if the dummies the next day, they don't get woken up because they don't have spice on the memory and these kind of things. It just was making more and more difficult. And all of these difficulties just came from the fact that we were dealing with services and ideas that were not controlled by ourselves. But anyway, all of this is implemented, and actually Swiss COVID has perfect COVID. And we were there, it was nice. We had done all of these things. We had spent another month designing all of these extra protections and there are many more protections. I haven't talked today about different things on servers that we built to make sure that privacy is actually maintained end to end. But then came this thing that, it turns out that COVID is not only transmitted when you're very close and your droplets get to other people. We also have this thing that the droplets may become small and then may become aerosols. There's a spread. And if you have a non-ventilated room, you can be contagious for other people further away if you spend enough time, like in a restaurant, in a club, in a meeting room, in any of these places where maybe ventilation is not so good. So we needed a complement, right? And again, we needed to think again, what kind of infrastructure we're going to build, what kind of data is going to be collected, what are the abuse opportunities, and how do we do this such that we limit the purpose. And now this may remind you to this little thing, because it turns out that now we have here one of these feedback loops. Our requirements that in the beginning were only notify people within 1.5 meters, 15 minutes. Now is we also need to notify people that are co-located in the same room for 1 hour, 2 hours, whatever the epidemiologists decide. So this kind of thing has changed, and now we need to deal with it. And that means, from a privacy perspective, that you need to go and redesign a lot of parts of the system. So the goal of this second part, indeed, is to notify everybody that has a shared and non-ventilated place with a SARS, with a COVID positive person. And this typically we think about restaurants and bars and clubs, but it's actually many more things that may be much more sensitive, like church, mosque, some other religious event, a lecture room, and depending, what is the kind of lecture that you have there, this may be more sensitive or not, because you may actually be interested on the lecture about LGBT rights, or you may be interested on lectures about a particular disease. And also you enter in kind of more private events that typically we don't even know they exist, like parties, AA meetings, reading groups, again, whose topic may be actually very sensitive because may say a lot of people and so forth. And we saw how centralized implementation started to appear. In Switzerland, we had social pass. I think in the German part, it was called Mindful. In the Italian part, I don't know if you inherited one of these two health applications, or if you have your own health, really not sure. And then these implementations, what they did is kind of just digitalize the current process, which is I take the paper, which would have my name and my phone, and I just digitalize it, and I just send it to a server. So you're creating databases of who went where, not only of the positive people, also the negative people, right? Everybody that is there will scan and send, and you will get all of this information about not only whether I went there, who went with me, how much, at what time, yeah, and maybe some more information even about what time we left and something like this. And all of this really with a unique identifier, and that would actually create the register of any event, because in these applications, in order to get your QR code that you could put on the table, you had to subscribe. So now if you want one of these things, you actually need to create, and we're creating register and register of things that, excuse me, right now they don't exist. And this is extremely important because it has to do with other fundamental rights that we have. We not only have the fundamental right to privacy, but we also have the fundamental right of association and liberty of association. You can associate with whomever you want for whatever topic you want. At the moment that we start registering who meets with whom for what, all of these kind of rights start to be in jeopardy. So we wanted to build something that doesn't do any of these things. And this is the system that we came up with. Here is a restaurant, but you can imagine this being a lecture room, a meeting room, or anything. And the idea is that the restaurant by itself, without registering anywhere, with the help of an app or a computer program, can generate a public key, private key pair. The private key, like in everything, is put on the pocket, on a drawer, whenever they want. And the public key, they encode a secure code that they put on the door, on the tables, and when people come, they scan the secure code. So essentially, they learn the public key, and then they encrypt in their own phones a record that says, I was at this restaurant at this time. The encryption is made in such a way that you not only use the public key, but you also use the time. So the public key, if you wish, evolves with time, because we make a combination of public key and timestamp. And then everybody does the same. Everybody does the same, and they have records on their phone. So these records on the phone are encrypted, right? If somebody seizes my phone, it is impossible for them to know where I was because they cannot decrypt. And then eventually, when a positive case is discovered, then the doctor will learn from the infected person, from the positive person, which places they have been and at what times, and then they would inform, and then the restaurant would receive an access code, and then they would upload the private key that before they had on the pocket. They will upload it together with the times, like, okay, so the infected person was there on Tuesday from 10 to 1. And this information is the information that everybody can retrieve. And then with these keys and these times, they can create the secret keys for every place and time instance. And then we do a trial decrypt operation with all of the records you have on the phone. If one of them succeeds to decrypt, that means that you were there. And again, you're shown a message that says, you should now call the hotline because you were in the room with this other people. And in this way, we have a system that in properties is very similar than the previous one, the Bluetooth one, in the sense that all information from the users is local. The information local by itself really doesn't reveal anything. It's all of these encryptions. The keys that are here is also, it doesn't even reveal the identities of the restaurants or anything unless you have been there. You don't know which keys correspond to which restaurant. It has no information about where this come from. And we don't have a registry of locations. We don't create any new registry because everybody can create this on the solitude of their homes. So from a privacy engineering perspective, I mean, this was very cool also because there we have more time. So we could use kind of nicer crypto and do things that were more advanced and solve problems that are not much as software engineering, but really on the privacy side. I'm happy to talk about those if you're interested. But when we came to the privacy engineering, again, to the rest of the system we built, we again discovered a whole new world of pain. Because it turns out that the operative system suppliers, aka Apple and Google, had something to say about how we build our system and what we upload. So they asked us to include a pop-up that when you're about to upload things, it actually asks the user, do you really want to upload something? Right? Again, if you remember before, this is something that inserts user-dependent time in the system that makes it hard to do what? Our dummy strategy. Because of course, once you have all of these uploads, you may also need to take care of the dummies that now have to take into account that there is also this other thing. And we had to redesign everything, authentication, to create a different type of voting, redesign what is the user experience to make sure that these constraints did not affect the privacy, redesign the payload because now you're uploading different things and a lot of these things. And essentially it meant for us to kind of go back to square one because privacy doesn't compose that easily. It is very hard to just have a private thing, then put another private thing and just get a combination of both. In general, there are these little things, the devil is in the details, that actually means that you have to think about both of them together. Remember the beginning of the talk, privacy by design means from the beginning I need to think about these things. And that meant that we really need to go back to square one, and we spent another month and a half kind of working with the developers on how to actually make sure that the new application was as privacy preserving once we included all of these new things as the previous. So just to finish, what are the key lessons? What privacy engineering is about is really about minimizing trust on others. And the way I propose to reason about is to help people. It's not about doing adversarial models. Well, it's a little bit, but it's about this purpose limitation. What is the purpose of my application, and how can I build a system that ensures technologically that even if you would want to misbehave, you couldn't, because there is nothing in the system that allows you to do that. The second thing I would like you to take home is that privacy engineering is go well beyond crypto. Like I presented today two crypto protocols. The Bluetooth one is a very simple hash and encrypt thing, nothing super magical. The presence tracing one, the one of the restaurants, actually has a very heavy privacy preserving advanced cryptography in there. But we did these two things, and still the privacy of the system kind of required us to work for more months on kind of making sure that all of the other elements were actually lifting the privacy properties from the crypto to the end-to-end interactions. And as much as crypto is more and more a kind of a very well-known science, and we have ways of doing cryptographic proofs and very systematic ways of analyzing them, even now automatic provers, right, that are great because they find all of these errors and they help so much. But there's no such good methods to descend that what I'm calling here the non-crypto privacy. You really need experts. Actually, during this time, we did consult with many countries on their strategies to do this thing, and we actually found errors and problems in reasoning because there is no many people that has this training, and we don't pay as much attention to that as maybe we should, because if you look at the privacy, a lot of the privacy problems that come with all of this and the news is not about it was not encrypted. It's really about there was metadata that was left, and then you can infer things. And the final one that goes with the title of the talk is that when you have an agile world where requirements change and you have to rely on service, privacy engineering is hard. I couldn't make this bigger and redder because my slide would explode. But it is so hard. Like it took us and requires so much effort, right? We were designing, redesign again and again. It was a continuous thing. It was not really kind of adding things on top. It was really redesigning. And the fact that you rely on platforms that will constrain the design, they can force your privacy definitions and they can decide what is the minimum or the maximum level of privacy you can achieve. It doesn't matter what you want. You will have to abide to whatever they give you. And services may or may not enable you to do their goals. And maybe you need to change service, or maybe there is no service that actually will allow to do what you want. And then you need to build your own service. And then we feel like we've gone to the past. And all of these changes require us to redesign. And for this, we need kind of a two-sided approach. On the one side, to make sure that researchers in privacy understand this thing and start thinking about how we can make more agile pets that don't require like us to kind of go back and redesign, but maybe have more composition. This is something that in the literature appears very little because, as I said, the mentality is very waterfally. So you never have to do that. Why would I design and spend the time of my PhD students and do something that's not needed on a paper? It is needed in reality. And the other point is that we're not going to be able to do agile pets as agile as this thing wants because of this point here. You want something that is purpose limited. And you do not change the purpose. If your pet can change the purpose so much, that means that your pet was bad from the beginning because it was not doing its job. So maybe we need to accept that privacy cannot be so agile, and maybe these agile service practices need to stop a little bit if we want to have all of this privacy protection in the world. So we need to find a way to meet in the middle, privacy engineers and software engineers, to find ways where we actually can build the system, because I can tell you that as we're moving right now, it is not going to be privacy in the world because it's just going to be impossible to build it. Thank you very much. And I will be so happy to hear your questions and your views from your side.